Good evening, all of you. How are you guys? Warm welcome to all of you for BYJU'S Exam Prep GATE Engineering Services PSU exam preparation. Okay, so you know that last class we discussed already the introductory part of the transient analysis of most important topic of the network theory, right? So in this session, now we just continue what we discussed, and those who joined only today, don't worry, I'm going to give you a quick recap and then go further. You will definitely follow, don't worry about that, okay? I just keep discussing whatever I discussed in the last class and take you along with me. Don't worry about that, okay? Well, so you can keep the comments or doubts or whatever you get. I just keep watching these and try to answer whatever the doubts you have. Okay, and let's try to start our discussion here. Okay, and one more important thing is that better you understand who I am, because there are some newcomers today, right? They should also understand who I am actually. So my name is Dr. Muneender Erukulla. You can see here. I did my master's and PhD from NIT Warangal. I have 22 years of experience in GATE, engineering services, PSU exam preparation. Okay, I used to guide the students. Lakhs of students I have guided. I taught more than 250 batches for GATE, ESE, PSU exam prep across the country. You understand all of you, okay? And I visited USA, Hong Kong, Malaysia, Korea, and Singapore to present some of my research articles in the international conferences of most prestigious international conferences, IEEE and IET, and some of the prestigious international journals. Okay, and I am supervising 4 PhD scholars on smart grid technology, which is the most advanced topic. Okay, using artificial intelligence techniques, and my area of expertise is network theory, control systems, and power systems. So I'm going to take in future, okay, some important topics. I'm going to discuss some important topics of even not only network theory, but also the control systems and the power systems, important topics, okay? And better you subscribe to the YouTube channel, and then you will get the notifications and updates very frequently on the regular basis. Got it, all of you, okay? Well, so let's move on to the subject. At the end, I will give you my Telegram group, okay? Then you can also join that. I just keep posting the important updates in that also whenever I'm going to take the classes. And you can also post the doubts in that particular Telegram channel, okay? What are the group that I'm going to share with you? I'm going to share it at the end, okay? At the end of my session. And I will, keep clarifying your doubts as well on the regular basis. What are the doubts you get, like network theory, control systems, or power system? You just put the doubts when you prepare, okay? When you just face the difficulty, you just interact with me through that particular Telegram channel, okay? Well, last class, I told you that, the initial conditions of RLC elements, and I told you the most important point, the assumptions for the transient analysis. The given system must be stable, and the system is assumed to be operating in steady state until the disturbance takes place. Yes or no, all of you, okay? So 2 important assumptions we are making before we proceed further with the transient analysis. The first important assumption is what, Nana? Here, the given system is stable, and the second important assumption is what? The system is assumed to be operating in steady state until the disturbance takes place. Got it, all of you? Okay, well. So for that reason, you are getting here the t equal to 0 minus conditions is equal to t equal to minus infinity conditions. Okay, so I already explained you how do you construct the t equal to 0 minus or minus infinity equivalent circuit. That is, resistor remain resistor, inductor becomes short circuit because I'm applying the DC excitation here, DC circuits I'm trying to discuss here. Under DC conditions, obviously the inductor behaves like a short circuit and capacitor behaves like an open circuit. Okay, so here the capacitor is behaving like an open circuit. Similarly, if you want to know t equal to plus infinity conditions, the same circuit you will get, the resistor remain resistor, the inductor is replaced by the short circuit. Okay, this is an inductor. Okay, this is a capacitor, this is a capacitor here, and the capacitor becomes what? Open circuit. The only difference here, t equal to minus infinity is nothing but what? Before switching operation, and this is after switching operation. Before switching operation and after switching operation. You understand? Okay, well. Now, initial conditions, I told you already that IR of 0 plus, okay, is not equal to IR of 0 minus because of the reason the current through the resistor may change instantaneously and the voltage across the resistor may change instantaneously. May change instantaneously means what is that, Nana? They are not equal. Yes or no? Similarly, for the inductor, I concluded that, okay, current through the inductor may not change instantaneously. That means IL of 0 plus is equal to IL of 0 minus, okay, provided what? Provided, what is it provided? Voltage across the inductor is finite. Voltage across the inductor is finite. In case, okay, in case the VL of t is infinite or ideal impulse, then IL of 0 plus may not be equal to IL of 0 minus, okay, if VL is infinite or ideal impulse. We can call it what? Ideal impulse. Infinite magnitude, zero duration is always called what, Nana? Impulse. Yes or no? Okay, well, but voltage across the inductor may change instantaneously. Here current through the inductor may not change instantaneously, okay, provided voltage across the inductor is finite. Current through the inductor may change instantaneously provided voltage across the inductor is an ideal impulse or infinite magnitude. Voltage across the inductor may change instantaneously, okay, always. Got it, all of you? So it means that if you want to know t equal to 0 plus conditions, you must know what is the current flowing through the inductor at t equal to 0 minus conditions. That is very, very important point to be observed here. Okay. Then next one is what? Capacitor. Similarly, for the capacitor, we have discussed that voltage across the capacitor may not change instantaneously provided, okay, provided current through the capacitor is finite. What is that? Current through the capacitor is finite. And voltage across the capacitor may change instantaneously. May change means not equal. Okay, VC of 0 minus provided, okay, IC is infinite. You understand, all of you? Okay. And current through the capacitor may change instantaneously all the time. Okay. Voltage across the capacitor may not change instantaneously provided current through the capacitor is finite. Voltage across the capacitor may change instantaneously provided current through the capacitor is infinite or ideal impulse, and current through the capacitor may change instantaneously. Now, based on this, we understand clearly that our main objective is always, to find the initial conditions. So for initial conditions means what, Nana? T equal to 0 plus conditions immediately after the disturbance takes place or immediately after the switching operation. Yes or no? That means you need to construct the T equal to 0 plus equivalent circuit. So how do you construct the T equal to 0 plus equivalent circuit now? Okay, I know how to construct T equal to 0 minus equivalent circuit. I know how to construct T equal to minus infinity equivalent circuit because both are same. Yes or no? 0 minus, minus infinity, both are same, Nana. But plus infinity, again, I know how to construct T equal to plus infinity equivalent circuit. Okay, resistor remain resistor, inductor becomes short circuit, capacitor becomes open circuit. Under DC excitation I'm talking about. Yes or no? Okay, but I should also know how to construct T equal to 0 plus equivalent. That is a little challenging as compared to the T equal to plus infinity conditions and T equal to minus infinity conditions. So that we are going to discuss now. For that, you must have the concept of, okay, the behavior of the inductor and capacitor, especially with respect to the current, the inductor current, and voltage across the capacitor. The inductor current flowing through the inductor and voltage across the capacitor are very, very important. Okay, voltage across the capacitor may not change instantaneously. Current through the inductor may not change instantaneously, provided voltage across the inductor is finite, and here current through the capacitor is finite. Understand, all of you? Based on this information, okay, the T equal to 0 minus conditions, if you know, then you can conclude, okay, what is the equivalent of the inductor and capacitor at T equal to 0 plus. So that's what we are trying to do here now. Based on that, look at this now, how we are going to construct. Look at this. At T equal to 0 minus conditions, I'm trying to find. How do I find T equal to 0 minus conditions? Tell me. Based on that, I'm trying to construct T equal to 0 plus equivalent. Current through the resistor may change. Voltage across the resistor may change. The ratio VR by IR remains same. Therefore, resistor remains same as resistor at T equal to 0 plus. T equal to 0 minus, it is resistor. T equal to 0 plus also, it is resistor. So first one is over. Yes or no, all of you? Now coming to the second one. Coming to what? Second one, inductor. If you want to decide the equivalent of the inductor, first of all, you must have an information about what was the current flowing through the inductor at t equal to 0 minus. You agree, all of you? Okay. So let me find what was the current flowing through the inductor. Sir, how do you find what is the current flowing through the inductor at t equal to 0 minus? Construct t equal to 0 minus equivalent. Okay. T equal to 0 minus equivalent is same as what? T equal to minus infinity equivalent, yes or no? Means steady state before switching operation. So under steady state conditions, particularly for the DC excitation, when I'm talking about what is the equivalent circuit? T equal to 0 minus means before switching operation. Before switching operation. Resistor remain. Resistor. Inductor behaves like short circuit. Capacitor behaves like open circuit. Now find what is the current flowing through the inductor, okay, at t equal to 0 minus. Nothing but current flowing through the short circuit. So what is that current flowing through the short circuit you have to find? Yes or no, all of you? How much it might be? There are two options. Either it might be 0 or it might be a non-zero value. Yes or no? So the first case of the inductor, in the second case, there are two cases again you have. Okay. The first case of the inductor, okay. The first case of the inductor is that current flowing through the inductor was found to be 0 at t equal to 0 minus. That I'm taking it as the second case. In the third case, I'm taking it as current flowing through the inductor at t equal to 0 minus is some constant value I naught like 2 amperes or 5 amperes or minus 10 amperes, anything it might be. So IL of 0 minus was found to be 0 in one case, and IL of 0 minus is found to be some constant value I naught in the other case. There are two options you have after constructing t equal to 0 minus equivalent. You agree, all of you? Okay. So then what happens here, if the current flowing through the inductor is found to be 0 at t equal to 0 minus 0, okay, at t equal to 0 minus, okay, then current flowing through the inductor may not change instantaneously, right? For that reason, at t equal to 0 plus also it is 0, provided voltage across the inductor is finite. Then current 0 refers to what, Nana? Open circuit. Physically inductor is there, but immediately after the switching operation, it is behaving like an open circuit. So what are you going to do now at t equal to 0 plus equivalent circuit when you construct? Replace the inductor by open circuit. If at all current flowing through the inductor at t equal to 0 minus was found to be what? 0. You understand? Okay. Well, now in case if the current flowing through the inductor was found to be I naught at t equal to 0 minus, then replace it by an equivalent current source, because the same current flows with a parallel inductor model. This is what the parallel inductor model, Nana. You understand? In case if I naught is 0, what happens? You get the same equivalent circuit. Look at this. If I naught is 0, it's an open circuit. Yes or no? So it looks like the same as previous case. But when current flowing through the inductor was found to be I naught, some 10 amperes, minus 5 amperes, something like that, then replace it by, okay, and with an equivalent current source. The same I naught value I'm placing here. You understand, all of you? The same I naught value. What is I naught actually here? Whatever the current was flowing at t equal to 0 minus through the inductor with a parallel inductor model. Got it, all of you? Okay. This is a very, very important point to be observed. Entire transients will move around this table, Nana. If you understand this table properly, na, you can play with the transients. I can give you an assurance for that. But you have to understand first of all this particular table. That's why this table I'm going to explain you, okay, while discussing even the problems. I just keep on recollecting this table once again so that, you know, it should fix in your mind. Okay, even in your dreams also you should understand, you know, okay, what is the equivalent of the inductor? Immediately you should tell that there are two options. What was the current flowing through the inductor at t equal to 0 minus? Was it 0? Then open circuit. Was it some 10 amperes? Then it is equivalent to a current source with a parallel inductor model. Got it? Okay. Next. Now fourth one. What is the fourth one? Capacitor. Now similarly for capacitor also, the equivalent circuit of the capacitor, it depends upon the equivalent circuit of the capacitor t equal to 0 plus depends upon what was the voltage across the capacitor t equal to 0 minus. So just see first of all what is the voltage across the capacitor t equal to 0 minus. The first case I am taking it as Vc of 0 minus is 0. The second case I am taking it as some V0. There are two possibilities. So how do I find voltage across the capacitor t equal to 0 minus? Don't you know how to construct t equal to 0 minus equivalent, Nana? Yes or no? What is the equivalent circuit at t equal to 0 minus? Tell me. Resistor remain, resistor. Inductor becomes short circuit. Capacitor behaves like open circuit. Find voltage across the open terminals, nothing but voltage across the capacitor. Because physically capacitor is there acting like an open circuit. That's it. You understand? Okay. Now find that voltage. Was it 0 at t equal to 0 minus? Then at t equal to 0 plus also it is 0. Voltage 0 refers to what? Short circuit. Therefore, at t equal to 0 plus, the capacitor is behaving like a short circuit. You understand, okay? At t equal to 0 plus, it is behaving like a short circuit. Now, another option is there. What is that? What was the voltage across the capacitor at t equal to 0 minus? It might be some 10 volts. If it is 0, okay, short circuit. If it is not 0, some other value, let us say, some 20 volts or minus 10 volts, something like that, then what will happen here? Then it is replaced by an equivalent voltage source with a series capacitor model. This is a capacitor, this is an inductor. But they are behaving like what? Okay, here in this case, we are replacing it by open circuit. Here it is replaced by the short circuit. There is a capacitor. Don't forget that there is a capacitor. Okay. Well, let me check. Some people are actually asking the doubts here. Okay, some people are chatting. I think all of you following that. Any doubts? If you have, please put in the comment box. I will definitely clarify the doubts now. Okay. Well, let me check once again here. Good evening. Good evening. Okay, Sai Soumya, hi, AKG. Who is this AKG? Full name, please. Hi. Okay, great. Now, here, let us proceed based on this, okay, to find the 0 plus conditions, initial conditions. How do you find those initial conditions, let us say? I hope you understand this equivalent circuits, right? So, what is the equivalent circuit at t equal to 0 plus? Tell me. Switching operation done. T equal to 0 plus means after switching operation, okay. Now, resistor remain. Resistor, inductor is behaving like what? Hold here for a moment and just see what was the current flowing through the inductor at t equal to 0 minus. Was it 0? Then replace it by open circuit. Was it some 10 ampere? Then replace it by an equivalent current source with a parallel inductor model. That's it. Capacitor, okay. Take a pause here and then check once again here. What was the voltage across the capacitor at t equal to 0 minus? Was it 0? Then replace it with the short circuit. Okay. Was it some 10 volts? Then replace it by an equivalent voltage source, the same value V0 and with a series capacitor model. So this is what the conclusion of this table. I told you already that this table is very, very important. Nana. Entire transient analysis will move around, okay, this particular table only. And I also clearly explained you that t equal to 0 minus conditions. How do you find that? Simply just constructing steady state conditions before switching operation. I told you already that. Okay. Now, coming to the step-by-step procedure. To avoid all the confusions, I'm just hereby proposing a step-by-step procedure, okay, to find t equal to 0 plus conditions. Because initial conditions are very important for all of us, okay, in order to find the time response. Because ultimate objective is to find the time response. Okay, to find the time response, initial conditions are required. T equal to 0 plus conditions are required. So in the exam, most of the questions, if you see here, okay, t equal to 0 plus conditions. Generally, they will be asking the questions on t equal to 0 plus conditions. So how do you find that? Step 1. Step 1. T equal to 0 plus conditions are asked in the exam, let us say. You have to follow this step-by-step procedure. Step 1. What is step 1, Anna? Tell me. First, construct t equal to 0 minus equivalent and find what is the current flowing through the inductor and what is the voltage across the capacitor. Just now I told you that to find t equal to 0 plus conditions, you must know what is happening in the inductor, current flowing through the inductor, and what is happening in the capacitor, that is voltage across the capacitor. Okay, based on that, you are going to construct the equivalent circuit. Yes or no, all of you, okay? Well, so find t equal to 0 minus, conditions, that is current through the inductor and voltage across the capacitor. Okay, by constructing t equal to 0 minus equivalent. In case in the question, suppose he is asking what is the current flowing through an inductor at t equal to 0 plus, then you know that current through the inductor may not change instantaneously. IL of 0 plus is equal to IL of 0 minus. And suppose if he is asking VC of 0 plus, then VC of 0 plus is equal to VC of 0 minus. Voltage across the capacitor may not change instantaneously. Immediately you can conclude that, okay, IL of 0 plus is equal to IL of 0 minus and VC of 0 plus is equal to VC of 0 minus. You got the point, all of you? Okay, so this is how you are going to find, and there is no need to construct t equal to 0 plus in case if current through the inductor and voltage across the capacitor are asked at t equal to 0 plus. Simply you construct t equal to 0 minus and just conclude that IL of 0 plus is equal to IL of 0 minus and VC of 0 plus is equal to VC of 0 minus. There ends the matter. But suppose it is asked like this, IR of 0 plus, okay, VR of 0 plus, VR of 0 plus, IC of 0 plus, VL of 0 plus. What does it mean, Anna? Other than current through the inductor voltage across the capacitor is asked. Other than current through the inductor voltage across the capacitor is asked, then certainly you have to construct T equal to 0 plus equivalent circuit. Certainly you have to construct T equal to 0 plus equivalent circuit. Then only you can find those quantities. See, there are totally 6 quantities, Nana. What are they? Tell me. One is IR of 0 plus, other is VR of 0 plus, then IL of 0 plus, VL of 0 plus, IC of 0 plus, VC of 0 plus. Totally 6 quantities are there. Out of these 6 quantities, IL of 0 plus and VC of 0 plus can be determined from step 1, that is just by constructing T equal to 0 minus equivalent. But the rest of the quantities, other than current through inductor and voltage across the capacitor, you have to construct T equal to 0 plus. Usually, when T equal to 0 minus conditions are asked, you have to construct T equal to 0 minus equivalent. When T equal to minus infinity equivalent circuit is asked, of course both are same. I told you that 0 minus minus infinity both are same. Then you have to construct T equal to minus infinity equivalent circuit. When T equal to plus infinity conditions are asked, then you are supposed to construct the corresponding equivalent circuit to T equal to infinite conditions. You understand, all of you? When T equal to 0 plus conditions are asked, then you are supposed to construct T equal to 0 plus equivalent circuit, but this is exempted for 2 important quantities. One is current through the inductor, the other is the voltage across the capacitor. You understand, all of you? For that, the T equal to 0 plus equivalent circuit is not required. Simply from the first step itself, you are going to get it. Okay? Then, so second step, it's very clear. I have written clearly. Please note down this. Construct T equal to 0 plus equivalent circuit for IR of 0 plus, VR of 0 plus, IC of 0 plus, and VL of 0 plus. Got it, all of you? Okay? Well, other than current through inductor, voltage across capacitor, okay? Other than current through inductor, voltage across capacitor, you have to go for step 2. Fix it. That's it. You just fix in your mind. Now coming to step 3. Step 3. There are initial conditions of derivative terms. Initial conditions are of 2 types. One is the non-derivative terms, normal terms. The other are what? Derivative terms. It depends upon the order of the differential equation. Yes or no? Okay. You might have studied in your mathematics. Differential equation order, right? Order of the differential equation. Based on that, how many arbitrary constants will come? Okay, you know how many arbitrary constants will come, right? So nth order differential equation, n arbitrary constants are required. Okay, nth order differential equation, n arbitrary constants are required. Okay, suppose 10th order differential equation, 10 arbitrary constants are required. Second order system, let us say, because generally in our electric circuits, we have second order. Highest order is what? Second order. Then 2 arbitrary constants required. Yes or no, all of you? First order, only 1 arbitrary constant is required. So number of initial conditions required is equal to what? Number of arbitrary constants, or order of the differential equation. For that reason, you have, okay, if you want I of 0 plus or di of 0 plus by dt is also there. Yes or no, all of you? Sometimes in the exam, he may ask you d square I of 0 plus by dt square. Okay. Suppose if I of 0 plus is equal to 10 ampere, then what is di of 0 plus by dt? Most of the times when I ask this question in the class, people give me some surprises. They immediately tell that, can I expect the answer from you here? When I of 0 plus is equal to 10 amperes, okay, what is di of 0 plus by dt? Can anybody answer? Yes? Will you please answer this question, all of you? 1? How it is 1? How it is 1? What about d square I of 0 plus by dt square, Rana? How about this? How about this? Anybody? 1 is wrong answer, Nana, AKG. Anybody? Yes. If I of 0 plus is equal to 10 amperes, what is di of 0 plus by dt? 0. Zero is also wrong answer. It is not 0. That is what I'm saying. Don't differentiate this with respect to time. That is wrong. You understand? If you know I of t as a function of time, then differentiate this with respect to time, then apply t equal to 0 plus conditions to this. You understand? Okay. Find I of t, then substitute t equal to 0 plus, then you will get I of 0 plus. Then differentiate that I of t with respect to time, then you will get di of t by dt, then you apply t equal to 0 plus conditions. Then again differentiate that, di of t by dt, that will become what? D square I of t by dt square, then you apply t equal to 0 plus conditions. So don't simply differentiate this value, that is completely wrong. You understand? Okay, that is completely wrong. I hope you understand the point. For that reason, we need to put some special efforts to find I of 0 plus, di of 0 plus by dt, d square I of 0 plus by dt square, and so on and so forth. For that reason, I am proposing here the third step. First, you obtain the linear differential equation for t greater than 0. If you have the differential equation with you by using either KCL or KVL or a combination of both, KCL means node analysis you can apply, KVL means mesh analysis you can apply. With the combination of KCL and KVL, finally you get the differential equation in the desired quantities. Suppose you want di of 0 plus by dt, then entire differential equation you can obtain in terms of, di of 0 plus by dt. That differential equation must consist of di of 0 plus by dt. Then apply t equal to 0 plus conditions to it. So, like that you can proceed. That entire differential equation can be differentiated again with respect to time to get the higher order terms. Then apply t equal to 0 plus conditions. So there is a procedure. I'm going to explain you this while doing the problems, don't worry. But the third step is required here to determine what? The conclusion is what? The third step is required in order to determine the initial conditions of derivative terms. I hope you're following. Okay, the initial conditions of derivative terms can be determined, here using the third step. I hope you're following. So I told you already the difference between the mathematics class and this network theory class as far as transient analysis is concerned. In mathematics class, the mathematics teacher is really kind enough to provide you the differential equation as well as the initial conditions. The only thing you have to solve the differential equation. Okay? But I'm not kind enough. I'm not going to give you the differential equation nor the initial conditions. I'm going to give you one beautiful electric circuit and you guys are going to obtain the differential equation with the help of KCL and KVL, and then you have to solve. While solving, you definitely come across the initial conditions, right? Differential equation, if you want to solve, definitely you require initial conditions. For that, you have to approach the circuit once again. So from the circuit you are getting the differential equations, from the circuit you are getting the initial conditions, then you are finding the total time response, which is of our ultimate objective. I hope you are following this. Okay, so look at the question that what we are going to discuss here. Then you will understand how we are applying this step-by-step approach. Just take a pen and paper, just work along with me and keep calculator aside, okay? In case if you find any difficulty in the calculations, then just keep enjoying the class while involving the calculation. Okay, not just simply watching the lecture, you won't get any benefit, I'm telling you. Of course, you may get benefit, but you get more benefit if you just work with your pen and paper. Okay, look at this. I'm going to solve certain questions here. So conclusion, I would like to give that. Okay, step 1, construct t equal to 0 minus equivalent and get IL of 0 minus VC of 0 minus. Step 2, construct t equal to 0 plus equivalent. I'll go for step 2 only when I want other than current through inductor, voltage cross capacitor. It is asked in the exam or in the question. Then I'll go for step 3 when I want the initial conditions of derivative terms. Okay, totally 3 steps are there, right? Now, here, the first question I'm starting with. The given circuit was operating in steady state for a long time, okay, with the switch K kept open. The given circuit was operating in steady state with the switch K kept open, okay, and at t equal to 0, the switch is closed. At t equal to 0, the switch is closed. You understand all of you, okay? Now determine I of 0 plus, d I of 0 plus by dt, d square I of 0 plus by dt square. If V is equal to 10 volt, R is equal to 1 ohm, L is equal to 0.1 Henry. Okay, so let's work on this. Now let's proceed step by step. So what do you want? 0 plus conditions clearly. Yes or no? You want what? 0 plus conditions. Let's proceed here. To find the 0 plus conditions, first you have to see what is asked actually here. I of 0 plus. What is I? I'm asking you what is I. Is it current through inductor? Yes, sir, current through inductor. Sir, it is also current through resistor, but it's a current through inductor. Okay, that's why I told you current through resistor, voltage across resistor may change instantaneously. These are the two standard statements. Why I'm using carefully may change instantaneously, because sometimes the resistor might be in series with the inductor. Now current through the resistor should follow just simply current through the inductor, because current through the inductor may not change instantaneously, right? Now inductor is offering inertia in the form of current, then obviously the current flowing through the resistor should also follow the current flowing through the inductor. Okay, so I of t is the current flowing through the inductor. So current through resistor, no, but current through inductor I have to take. Okay, similarly, when resistor and capacitor both are across each other, okay, when V is given, then it is a voltage across the capacitor. Of course, voltage across the resistor, but it is a voltage across capacitor. Now, voltage across the resistor should follow the voltage across the capacitor, because voltage across the capacitor may not change instantaneously. Got it, all of you? Okay. So let us proceed step by step. I of 0 plus is required for this particular problem. Suppose if this only question I of 0 plus is asked, what is the procedure? Tell me. Construct t equal to 0 minus equivalent. Get what is current flowing through the inductor at t equal to 0 minus. Okay. Then immediately conclude I of 0 plus is equal to I of 0 minus. I hope you are understanding this, right? Okay. Then look at this. How to construct t equal to 0 plus? You know. First find what is the current flowing through the inductor. Okay. Construct t equal to 0 minus equivalent. Then find current flowing through the short circuit, nothing but current flowing through the inductor. Then based on that, you can conclude whether the inductor is replaced by the open circuit or replaced by the equivalent current source. Okay, so let's do that. You know how to construct t equal to 0 minus equivalent, right? Before switching operation, resistor, inductor behaves like short circuit, capacitor behaves like open circuit. Yes or no, all of you? Then look at this. This equivalent circuit, t equal to 0 minus, okay, switching. Initially it is open or closed, tell me. Open, right? Open. Resistor remain resistor. Inductor is acting like a short circuit. Okay. Plus minus. This is V. This is an inductor. Can you charge the inductor keeping an open circuit here, Nana? Is it possible? Is it possible? Okay. Can you charge the inductor by keeping an open circuit here? Is it possible? Okay. Actually, this is I of 0 minus. I and IL of 0 minus both are same. Yes or no? Because the loop current, right, that is flowing through the resistor, the inductor. Okay, then I of 0 minus is what? 0. Since I is current flowing through the inductor, I can immediately conclude that I of 0 plus is equal to I of 0 minus is equal to 0. This is what my answer for the first question I of 0 plus. Is it clear, all of you? Okay, this is step 1, Nana. So step 1 itself, I got what is the current flowing to the inductor, right? Then should I go for step 2 now, or shall I skip this step? I don't have to construct t equal to 0 plus equivalent here in this context. According to the step-by-step procedure what I've explained, here the second step is not required, but third step is required. What is the third step, Nana? Step 3 is that, okay, just to avoid the confusions, okay, I'm just taking you in a step-by-step manner. Once you get experienced, you know, there is no need to do completely in the step-by-step, directly you can attack the problem. Okay, just to avoid the confusion. What you do is, when you want d I of 0 plus by dt or d square I of 0 plus by dt square, first you obtain the differential equation in terms of the desired quantities. What is the desired quantities? Tell me here. What is the desired quantity here? d I of 0 plus by dt and d square I of 0 plus by dt square. That means what? You require the equation in terms of the current. Generally, the equations in terms of the currents can be obtained using Kirchhoff's voltage law. Yes or no? Using Kirchhoff's voltage law. So tell me now, if I apply Kirchhoff's voltage law in this particular circuit, okay, obtain the linear differential equation for t greater than 0 using either KVL or KCL or both. In this context, KVL is enough because the equation in terms of I require. So tell me now, what do you get? So L di by dt, right? Look at this. I into R plus, then what? L di by dt is equal to capital V. Equation 1, Nana. Now, what I want actually here, d I of 0 plus by dt, right? So what I do is, I apply t equal to 0 plus conditions to equation 1. Then what will I get? Tell me here. I of 0 plus into r plus L d I of 0 plus by dt, okay, is equal to capital V. You know that I of 0 plus value was already 0. Yes or no? Then it is 0. Then remaining is what? D I of 0 plus by dt is equal to, can you please tell me the answer here? All of you should involve in the calculation. V is equal to 10 volt, L is equal to 0.1, so 10 by 0.1, what is this? 100 ampere per second. What is this? 100 ampere per second. You got the point, all of you? Okay, I hope you got this answer. Okay, well, now coming to d square I of 0 plus by dt square. I told you already that when d I of 0 plus by dt is 100 ampere per second, okay, you can't differentiate this to get the value of d square I of 0 plus by dt square. You have to find by differentiating this equation, not by differentiating this. You understand? Okay. Don't differentiate d I of 0 plus by dt. Instead, you differentiate equation 1. Tell me, differentiating equation 1, d by dt of equation 1 will give you, obviously, okay, r into di by dt plus L d square I by dt square, okay, is equal to, because that is a constant voltage, when you differentiate it, you will get 0, because that is a DC excitation. When you differentiate, what will happen? Tell me here, when you differentiate this equation, what do you get, Nana? You will get, when you differentiate this equation, okay, d I by dt into r plus L d square I by dt square, okay, is equal to, because it is a constant value, you are going to get 0. Now tell me, let us apply, this is equation 2. Now apply t equal to 0 plus conditions to equation 2. Okay, if you have any doubts, please put your doubts in the comment box. I will definitely answer, okay, wherever you stuck, wherever you do not understand, don't compromise, okay, just simply put the, doubt over there. I will definitely, answer it. Yes, AKG, dt square in the equation 2. Yes, exactly. So the objective is what? D square I by dt square. Let us apply t equal to 0 plus conditions. So r into d I of 0 plus by dt plus L into d square I of 0 plus by dt square. This is dt square. Okay, got it. This is dt square, Nana. Very good. Dt square is equal to 0. Okay, so what do you get, Nana, here? R value, you know very well. How much R value? What is the R value? Or else I can just put it here. D square I of 0 plus by dt square is equal to minus R by L d I of 0 plus by dt. Yes or no? Okay. So what do you get, Nana, here? R value, you know that it is 1 ohm by 0.1. This is minus already. And this is 100. Therefore, minus 1000 ampere per second square. Following all of you? Ampere per second square is the answer. That is minus 1000 ampere per second square. Hope all of you understand this. Okay. How much you got? d I of 0 plus by dt is 100 ampere per second. And you know that R value is what? R value is 1 ohm. L value is 0.1. I hope you understand this particular problem now. So we are able to find I of 0 plus, d I of 0 plus by dt, d square I of 0 plus by dt square. That's it. Simply by step procedure. Now coming to second problem. When we discuss the second problem, then you will understand the difference between these two, the step 1, step 2, step 3, how we are going to apply. In the second problem, we are going to come across all 3 steps we are supposed to follow here, because look at this. This is an RC circuit. Look at this. And what is asking? Here find I of 0 plus, d I of 0 plus by dt, d square I of 0 plus by dt square. So normal term, initial conditions I of 0 plus, and derivative terms d I of 0 plus by dt and d square I of 0 plus by dt square. Whenever the derivative terms are given, usually you have to go for what? Step 3. And step 1 is mandatory, because if you want to get the 0 plus conditions, certainly you must know what was the current flowing through the inductor at t equal to 0 minus, what was the voltage across the capacitor at t equal to 0 minus. But step 2, is it required or not? That we have to cross check once. What is this I, Nana? Tell me. Is it current through inductor or other than current through inductor? Tell me, all of you. Okay, is it current through inductor or other than current through inductor? There is no inductor. It is current through capacitor or current through resistor. And current through resistor may change instantaneously. Current through capacitor may change instantaneously. Other than current through inductor, voltage across capacitor t equal to 0 plus, you have to go for step 2. So let me start now. Step 1, step 2, step 3, all are required to find these 3 quantities. For I of 0 plus, you require step 2. For that, step 1 is required. For d I of 0 plus by dt and d square I of 0 plus by dt square, step 3 is required. You understand all of you, okay? Well, so now let me do that. So you know how to construct t equal to 0 plus equivalent, right? Resistor remain resistor. Inductor, it depends upon what was the current flowing through the inductor, t equal to 0 minus. Was it 0? Then it is open circuit. Was it constant value? Then it is the current source with a equivalent, parallel inductor model. Then capacitor, what was the voltage across the capacitor? Was it 0? Then it is replaced by the short circuit. Was it some constant value at t equal to 0 minus? Then it is replaced by voltage source with a series capacitor model. Okay. So how to construct t equal to 0 minus and minus infinity equivalent circuit? Nana. Before switching operation, no switching operation taken place here. Resistor remain resistor, inductor replaced by short circuit, capacitor replaced by open circuit, because we have given DC excitation. So let us see that now. So first step, step 1, construct t equal to 0 minus equivalent. Can you please tell me? And what is your objective in this step 1, Nana? Always remember, in step 1, we just construct t equal to 0 minus equivalent and find current through inductor and voltage across capacitor, irrespective of the problem that has been asked in the question. Doesn't matter what question it is, but step 1 you are implementing means construct t equal to 0 minus equivalent and find what was the current flowing through the inductor and what was the voltage across the capacitor. Don't find what was the current flowing through the capacitor and what was the voltage across the inductor. No use, because they change instantaneously. They may change instantaneously. Don't find what was the current flowing through the resistor and what was the voltage across the resistor, because they may change instantaneously. There is no use of finding those quantities. Only current through inductor and voltage across capacitor you are supposed to find. Tell me at t equal to 0 minus, at t equal to 0 minus, the switch is open, right? The switch is open, resistor remain resistor, and capacitor is acting like open circuit, okay? And this is what the DC source given. This is what the capacitor. I'm just trying to highlight the capacitor here. Find VC of 0 minus irrespective of the question. Okay? VC of 0 minus. What is VC of 0 minus, Nana? Can you charge this capacitor keeping an open circuit here? Is it possible? Is it possible? Okay? One of you giving an answer, VC of 0 minus is equal to 10 volts. Can you get the charging of the capacitor keeping an open circuit here? Is it possible? You cannot charge the capacitor by keeping an open circuit. Therefore, VC of 0 minus is 0. That's it. Now let us go for t equal to 0 plus equivalent. My objective in t equal to 0 minus is always finding voltage across capacitor t equal to 0 minus. That's it. Now, step 2. What is step 2, Nana? Construct t equal to 0 plus equivalent. Construct t equal to 0 plus equivalent. Tell me. At t equal to 0 plus means what? Based on the direction of the switch, it is clear that you are closing the switch at t equal to 0. It means it is closed condition, right? Resistor remain resistor. Now, capacitor, it depends upon what was the voltage across capacitor at t equal to 0 minus. Tell me what was that value you got? 0. When voltage across the capacitor was 0 at t equal to 0 minus, what is the equivalent of the capacitor at t equal to 0 plus, Nana? Just see this particular table, we made it very clear. If it was 0, then replaced by it's a short circuit. That's it, simple. So I just replaced it by the short circuit. Physically there is a capacitor, but acting like a short circuit now in this context, then it is actually voltage V. This is R. Tell me now, what is I of 0 plus? Simple, I of 0 plus is equal to, okay, V by R. What is V? Can you tell me? V is equal to 10 volt. R is equal to 1000 ohm. Yes or no? So it is 1 by 100, nothing but 0.01 ampere. Hope you understand this. 0.01 ampere. Yes. Got it? Yes, 0, short circuit. Very good. Very good. So now, tell me here, how do you find di of 0 plus by dt? For that, I told you already clearly that obtain the differential equation for t greater than 0. To make you understand, I am taking very simple problems to apply the concepts in an easy manner. Once you know, okay, how to apply the concepts to the given circuits, then we can go for the different problems, okay? So first 4 problems I'm taking RL series, RC series, RL parallel, RC parallel. After that, I'm going to take a different varieties of problems, and I'm going to give you some updates in the procedure also. Some small updates I'm going to keep, so that exam point of view, how you are going to answer the question. Because such simple questions may or may not be asked in the exam, okay? But I'm going to give you some important questions, okay, in the upcoming, slides. Then our upcoming sessions I'm going to discuss. In that case, I'm going to take some problems which were asked in the previous GATE and previous ESE exams. Okay, well, now let us see here. Let us apply t equal to t greater than 0. What is the differential equation? Can you please tell me? Since it is an RC series circuit, okay, voltage across this I into R, voltage across this 1 by C integral I dt, yes or no, is equal to what? Capital V. Therefore, you will get I of t into R plus 1 by C integral I of t dt. Hope you are following equation 1. But what is your objective here? di of 0 plus by dt. Do you find any term in this particular equation? No. What you do is you differentiate this equation with respect to time. So when you differentiate it, d of 1 by dt is equal to, okay, di by dt or di of t by dt into R plus 1 by C I is equal to 0. This is equation 2. Now I got the term here, di of t by dt, I of t, yes or no? Now let me apply t equal to 0 plus conditions to equation 2. What will I get, Nana? Tell me. If I apply, what will I get? Tell me. I will get here, in this case, okay, di of 0 plus by dt is equal to minus 1 by RC into I of 0 plus. You understand? Okay. What is 1 by RC? R value, how much, Nana, given? 1 kilo ohm, 1 into 10 power 3. And this is 1 into 10 power minus 6. And this is 0.01. Already we determined this value, 0.01. Can you please tell me the value here? I just give you directly here. I have already calculated. Just to save the time, I'm directly giving you. I got that answer here. I'm just giving you. Yeah. Just note down that answer here. You will get di of 0 plus by dt is nothing but 10 power 4 ampere per second. You got it, okay? 10 power 4 ampere per second. Got it, all of you? Okay. Yes, yes. 0.01 kilo. Just check once. Are you getting 10 power 4 ampere per second? Minus 10 power 4, right? It is minus 10 power 4, Nana. Minus or plus? Look at this. Yes, minus 10 power 4 or no. Yes, you're right. 10 only, right? Okay. You will get now here minus 10 ampere. Sorry, minus 10 ampere per second. Correct, Nana. 0.01 k is nothing but what? Okay, 10 only, right? But put negative sign because already negative sign is here. Okay. Now coming to d square I of 0 plus by dt square. How do you get that? Just differentiate once again. Okay, equation 2 with respect to t. What do you get, Nana, here? Okay, d square I of t by dt square into R plus 1 by C di of t by dt. Yes or no? Is equal to 0. Equation 3. Now, from this we understand that d square I of t by dt square is equal to minus 1 by RC di of t by dt. Yes or no? For this, if you apply t equal to 0 plus conditions, then what do you get, Nana? D square I of 0 plus by dt square is equal to minus 1 by R value, how much again here? 1 into 10 power 3. C is 1 into 10 power minus 6 into what is this value? Already we got it. Minus 10, right? Minus 10. So then you are going to get the answer I'm directly writing here. Please note down. You are going to get 10 power 4, okay, ampere per second square. You are following, all of you? Very good, AKG. What is your full name? I am able to see only your, short name, okay? Will you please expand your name? Very good. You got that right answer, 10 power 4, Nana. Very good. Is it minus 10 power 4? Anil Kumar. Oh, very good. Anil Kumar. Amit Kumar. Yeah, Amit Kumar. Yes, Amit Kumar. Very good. So 10 power 4, is it plus 10 power 4 or minus 10 power 4, Amit? Good. 10 power 4 plus 10 power 4 nana. Yes. Coming to now next question. Simple. Now this is a standard procedure. Let us see what is asked, and based on that how many steps are required. Simply you can feed it. That's it. There is absolutely no confusion. To avoid the confusions only, I'm teaching you in a step-by-step manner. Okay. So let us solve 2 more problems and try to wind up this, and next day I'm going to discuss all gate point of view questions here. You understand? Okay. Well, so now coming to this. Look at this. He's asking v of 0 plus dv of 0 plus by dt, d square v of 0 plus by dt square. Nana. What is v? The node voltage here with respect to this. But what is this node voltage? Is it voltage across resistor or voltage across capacitor? Of course, voltage across resistor, but I consider it as a voltage across capacitor because voltage across a capacitor may not change instantaneously. Now, the voltage across resistor should also follow the voltage across the capacitor. Yes or no? Okay. Then, step 1, enough. Okay. For voltage across capacitor, current through inductor, step 1 is enough. Agree or not? Okay. So, let's do that. Let's do that. What is step 1, Nana? Construct t equal to 0 minus equivalent. What is t equal to 0 minus equivalent? Look at the switching operation. Before switching operation means switch open or close. Amit, look at the direction of the switch. Initially, is it open or closed? T equal to 0 minus. It was closed condition. Yes or no? Okay. Therefore, look at this. T equal to 0 minus. It was in closed condition. Yes or no? The resistor remained resistor. Then capacitor is acting like what? T equal to 0 minus. Open circuit. And your objective is to find voltage across capacitor in this particular step. Anyway, the voltage V itself is what? Actually voltage across capacitor only. So, what is the voltage across capacitor? Okay, VC of 0 minus, which is nothing but V of 0 minus. Can you charge this capacitor keeping in a short circuit across it, Nana? Is it possible? Because this entire current is passing through the short circuit itself. How can you expect the charging of the capacitor keeping a short circuit across it, Nana? Okay? Yes, Amit. The switch is closed initially. Very good. So, what is this value now? V of 0 minus is how much, Nana? 0. Immediately you can conclude V of 0 plus is equal to V of 0 minus is equal to 0. Following? Okay? Done. Step 2 is not required because he is asking what is the voltage across capacitor. Okay? Current through inductor, voltage across capacitor doesn't require step 2. T equal to 0 plus is not required. Step 3. Okay? Step 3. Why step 3? Because derivative terms. Okay? Usually derivative terms can be determined using step 3. For that, you require the linear differential equation that should be obtained for t greater than 0 because you're looking for t equal to 0 plus conditions. Therefore, obtained for t greater than 0 using, because it is dv by dt of 0 plus, usually KCL is the most suitable in this particular context. Okay, so let us apply KCL or node analysis to get the equation. Tell me, how do you apply here? If you apply KCL at this node, okay, for t greater than 0, the switch is open condition. Yes or no? Current I is entering, V by R is leaving, okay, C dV by dt is leaving. Then what is the equation you are going to get? Tell me. V of t, right? V of t by R is the current plus C dV of t by dt is equal to capital I. Let's call it equation 1. So I think this equation contains the desired component dV by dt. Let us now apply t equal to 0 plus conditions to it. So if you apply t equal to 0 plus conditions to the equation 1, then what do you get, Nana? V of 0 plus by R plus C dV of 0 plus by dt is equal to capital I. You understand? Okay. So tell me now, what is V of 0 plus here? What is the value you got? 0 already, yes or no? So what is dV of 0 plus by dt, Nana? Is equal to I by C. Okay. So initially I'm taking very simple problems to get the command on the concepts, how to apply those concepts to the electric circuits given. Okay. Then initially some 4 problems I have taken, very simple. Of course, later on also I'm taking simple problems only, but whatever the questions were asked in the previous GATE or engineering service exams, I'm going to discuss. You understand all of you? Okay. So just, patiently you just attend the class and just put your pen, paper, calculator aside. Okay. I mean, calculator also you just keep it with you, and whenever you the question is asked here. Try to put your pen and calculate and give me the answers in the comment box. Okay, it'll be great if you can answer the questions instantaneously. Okay, so let's do that. What is I, Nana, actually here? I is 1 ampere and C 1 microfarad. Tell me, 1 ampere by 10 power minus 6. Therefore, it is 10 power plus 6, okay, volts per second. I hope you got the answer, 10 power 6. Yes, Ankit, very good, Nana. Is it volts or volts per second, Ankit? Derivative term, right? Acceleration component, Nana. Very good. Now again differentiate because d square v of 0 plus by dt square is required, right? Therefore, d square v of 0 plus by dt square means you differentiate with respect to that equation 2. What is that equation 2 or equation 1? Equation 1, Nana, not 2. Equation 1. Then what do you get, Nana? Tell me. dv of t by dt into r, 1 by r, okay, plus c into d square v of t by dt square is equal to 0 because it's constant value. Tell me now. This is equation 2, Nana. Applying t equal to 0 plus conditions to equation 2, I'm just directly writing here d square v of 0 plus by dt square is equal to minus 1 by rc dv of 0 plus by dt. Tell me now, here minus 1 by, what is r? 1 kilo, 1 into 10 power 3. What is c? Okay, 1 into 10 power minus 6 into, what is dv of 0 plus by dt? 10 power 6. Can you please tell me what is that value then you are going to get? I'm just directly giving the value. Please tell me what is the answer you got? Minus 10 power 9. Yes, volts per second square. Clear, Amit? Okay, very good, very good. So this is how you are going to answer the questions. And the last question, let us see now here. V of 0 plus dv of 0 plus by dt, d square v of 0 plus by dt square. This is an RLC, parallel circuit. Look at this. What is V now in this case? Voltage across the resistor, voltage across the inductor. Other than voltage across the capacitor, what you have to do here? You are supposed to go for step 2. So what is step 1, Nana? Step 1. Tell me. T equal to 0 minus equivalent. Tell me T equal to 0 minus what is your objective? Current flowing through the inductor. The switch is closed already here, right? Okay, good. What about the inductor? Inductor is acting like a short circuit under steady state conditions before switching operation. Now my objective is to find current through the inductor in this particular step. Always irrespective of the problem, you are supposed to find what is the current flowing through the inductor or what is the voltage across the capacitor at T equal to 0 minus. Now tell me. Okay, I may take some 5 minutes extra to finish this problem. So what is IL of 0 minus? 0 ampere. So this will decide what is the voltage, what is the T equal to 0 plus equivalent. Because if you want to construct T equal to 0 plus equivalent, certainly you require what was the current flowing through the inductor T equal to 0 minus. Agree all of you? Okay, well. So now let us construct T equal to 0 plus equivalent here. Okay, T equal to 0 plus equivalent I'm trying to construct here. Tell me, how does it look like? Current source remain current source. This is step 2, Nana. T equal to 0 plus equivalent. Yeah. Switch is now open condition or closed condition? Tell me. Open. Resistor remain resistor. What about the capacitor? Okay. It's not capacitor, it's an inductor. Okay. It is wrongly placed. Look at this. This is an inductor given. I'm just correcting it, please, all of you. This is an inductor, Nana. What is an inductor? The inductor at T equal to 0 plus, the equivalent depends upon what was the current flowing through the inductor at T equal to 0 minus. What was the current actually? 0. So therefore, it is acting like open circuit or short circuit. Can you please tell me? Amit, is it open circuit or short circuit, Nana? It is open circuit because current flowing through the inductor was 0 at T equal to 0 minus. Then current may not change instantaneously in the inductor. Current 0 refers to open circuit. Therefore, it is replaced as open circuit. 0 and V of 0 plus now here, this is capital I, this is R. Now the voltage across these particular two terminals or V of 0 plus is nothing but voltage across the resistor. This entire current is passing through the resistor. V of 0 plus is equal to I into R. What is I value, Nana? Okay, what is that I value? Already 1 ampere, R value 1 kilo. Therefore, you got 1 into 10 power 3 volts. You got 10 power 3 volts. Yes or no? Okay, very good. Now, what about step 3? Step 3. For t greater than 0, using KCL, you obtain the linear differential equation. Agree, all of you? You obtain the linear differential equation using Kirchhoff's current law for t greater than 0. Tell me, what is that you're going to get? Okay? Tell me. KCL, I is entering, V by R is leaving. 1 by L integral V of t is nothing but current flowing through the inductor. You remember that? Okay, then I into R plus, sorry, V by R, right? V by R plus 1 by L integral V dt is equal to capital I. This equation is not sufficient to find the dV by dt of 0 plus because it doesn't have the term. So what we do is we differentiate this equation with respect to time. So it gives you 1 by R dV of or dV by dt, okay, dV by dt plus 1 by L V is equal to 0. Now you call it equation 2. Now t equal to 0 plus conditions to equation 2. Then dV of 0 plus by dt is equal to minus R by L, okay, V of 0 plus. So here actually you need to make some correction. The values actually what we were giving here, I is equal to, please correct it, I is equal to, I would like to give you, because generally the capacitor value is given, but we require what on a inductor value. Please rectify that. R is equal to 1 ohm, L is equal to 1 Henry, I is equal to 1 ampere. Please rectify this. I request all of you to rectify this mistake. L is equal to 1 Henry. Okay, then obviously this answer is also now will be changing because R is equal to what? 1 ohm. So 1 into 1, nothing but what? 1 volt only. Please correct it. Please correct it. Okay, the values were taken wrong, printed wrong actually on the slide. So I'm just correcting it. Now coming to this, what do you get, Nana? Minus 1 by 1 into 1, nothing but minus 1 volts per second. Okay, minus 1 volts per second. Now tell me here, what do you want? D square V by dt square. What do you have to do now? You have to differentiate this equation with respect to t. So what do you get here? Differentiating that equation with respect to t, you will get d square V by, look at that, d square V by dt square into 1 by R plus 1 by L, okay, dV by dt is equal to 0, Nana. So what do you get now? If you apply this equation 3, let us say, if you apply t equal to 0 plus conditions to equation 3, Nana, then what do you get? D square V of 0 plus by, following, okay, dt square. Please do it because it's completely mathematical. You are supposed to do it, okay. There is no other way. dV of 0 plus by dt, I'm directly writing here. Tell me, minus 1 by 1 into, what do you get here? Minus 1 again. So what do you get here? 1 volt per second square. This is how you are going to solve the problems. You understand, all of you, okay? So next class, I'm going to discuss some very, very interesting questions, okay? Very, very interesting questions I'm going to discuss in the next class, okay? And please keep posting your doubts in my Telegram group. I'm going to give you the Telegram group. Please note down that. Please note down that. Professor Muneender underscore gate EE and EC. You understand, okay? Professor Muneender underscore gate EE and EC. This is what my Telegram group that I'm maintaining, okay, for exclusively EC and EEE students. In future, what are the classes I'm going to take? In future, what are the classes I'm going to take? I'm going to keep, I'm going to post the important updates, the class schedules and everything, okay, in the YouTube sessions or free app classes or whatever it might be. I'm going to discuss the network theory, some important topics. Anyway, till 18th, I'm taking actually 13th September to 18th September. This transient analysis is completely finished now. It's not like, I'm just starting the class, but of course I try to reduce the number of examples because the time limitation, the time is limited here. I cannot discuss more number of questions, but I'm sure that you will get a good amount of idea on what transient analysis is. Okay, so network theory, control systems, and power systems. These three topics. In control systems, I'm going to take stability analysis, okay, state space analysis or frequency domain analysis, and in power systems also I'm going to take, okay, the stability analysis again in the power systems, fault analysis, and load flow analysis. And in network theory I'm already taking transient analysis, and in future, okay, I'm going to discuss some AC steady state analysis or DC steady state analysis, how to solve the problems, the DC circuits in a very, very simple manner. Easy techniques or shortcut techniques I'm going to discuss. Okay, so let's keep in touch here. You just, join this particular group. I will be definitely in touch with you, and any doubt you can post in this regarding not only subject, but about what are the courses that are happening in the BYJU'S exam prep. Okay, I can definitely give you the clarity in the group itself. Okay, so thank you for your patient listening and wish you all the best. And let's meet tomorrow and continue this session. Okay, thank you so much. Bye-bye. Take care. Done?